Having large-scale cities in motion presented challenges to achieving realistic effect simulations while maintaining dynamic movement throughout the shot. As London travels, it emits smoke and kicks up dust from the surrounding environment. To optimise these simulations and keep them consistent, volumetric wind simulations were pre-computed to model turbulence. For terrain interaction, we ran height maps as a starting point to inform the depth of the tracks and the deformation caused by the treads. PBD simulations were used to balance different materials depending on the nature of the terrain. Drier terrain resulted in larger chunks and finer subparticles, whereas wet terrain resulted in mud and puddles being churned up. As Salthagen gets ingested into the London gut, it slowly gets broken up over a sequence of shots. To maintain simplicity and continuity, animation drives the sequence, making sure it is continuous throughout. We used our BCM dynamic fracture workflow to achieve accurate deformation of different materials as Salthagen comes into contact with various shredders and saws. An advantage of using this technique is that once we had material presets assigned and assets available, it was easier for us to adjust and modify the sequence. Using Synapse, our sparse simulation framework, we took the multi-phase Medusa explosion and dynamically distributed the load between multiple machines, enabling us to run massive simulations that cover hundreds of kilometers. Burn maps, guided by animation, allowed us to naturally expand the emission sources to extend the fire and destruction across the city of Airhaven. We also took advantage of our Combustion 2 rig, which models oxygen and carbon ratios, to quickly and more accurately simulate this and other large-scale explosions that accumulated throughout the film.